Hello, Science Alliance. Hello, I am Lara. This is Theatre of Science. I am trained to teach physics up to A level, and I find these IGCSE lessons very exciting because that is basically what I'm doing. We are about halfway through our module on energy, and we're going right back to the first lesson to recap what we learned in the first lesson, or teach you it if you weren't here, that's fine. And I've sort of started out giving you a bit of brain exercise. This was very annoying if you didn't see the first lesson. Apologies. If you didn't see the first lesson, we were talking about energy stores. We were talking about how energy cannot be created, it can't be destroyed, it can just get shifted. And physicists talk about it being shifted from store to store. So there's a kinetic energy store, which means sort of something that is maybe moving. Kinetic sort of means movement. Gravitational potential energy, there's a chemical energy store, elastic strain. We'll recap these as we go along. So what I asked you in the kind of starter question was, if I hold an elastic band stretched, is its elastic energy store filling, or is it emptying, or is it unchanging? All right, let's have a talk about some of these stores then while we look at this. So we've looked at quite a lot how your body is a chemical store of energy. Well, you eat food and the food particles are stored in your body. You breathe in oxygen, and those food particles basically plus oxygen, that's a chemical energy store. And when they get together, you get a chemical reaction and energy is released, right? So your body is a chemical store of energy plus the oxygen that you breathe in. And when you move around, you could say that you shift energy from your chemical store to your kinetic energy store. And if you kept doing that, we understand, don't we, that you would have sort of used up some energy. You would have shifted so much energy to your kinetic store and also the thermal store. You can say thermal or you can say internal, but you would have made the air around you get warm because your body is warm. So that's why we need to keep eating food, because energy from our bodies is constantly getting shifted to these different stores. Okay, so if I stretch an elastic band, then are you okay with the fact that I'm shifting some energy from my chemical energy store to the elastic band, okay? Because the elastic band has started to move. You can feel, if you do this, that energy is being stored. There is energy there that has the potential to be released if you twang it out. Now, when I stretch it, when I'm in the act of actually stretching the elastic band, I am filling the elastic band's, this is all written backwards for me, so it's hard to find, the elastic band's elastic energy store. Is that okay? I'm filling it up. More and more energy is getting stored in the elastic band as I move, as I shift energy from my chemical store. But when I'm actually staying completely still, at that point, no more energy is getting shifted to the elastic band. So you would say, that's just my jumper, you would say that its elastic energy store is actually unchanging at that point. I was talking about that because I was trying to warm us up to a point which is sort of quite complicated but important to look at. And if you can understand this, you've probably understood energy stores. I'll warm up to it slowly, okay? A petrol-powered car is stationary. That means not moving. What kind of energy store is the petrol plus the oxygen around it of this car? You got to be careful. Petrol on its own is not particularly an energy store, but when the petrol reacts with the oxygen around it, then you get chemical reactions. So it's a chemical energy store. So let's say that this engine gets started and the car starts to move, all right? There's no trick questions here because this is already tricky enough. Where has energy been shifted to? So there was energy stored in the chemical energy store of the petrol plus the oxygen. We are now shifting some energy, okay? We're like burning petrol. Oxygen particles are moving around. There's chemical reactions happening. So the energy is getting shifted from the chemical store. Where is it going? There are 3 lines here because there are 3 different answers that you could give, which are all correct. Energy has been shifted to loads of different places. I'll tell you the answer because either you're going to be like, oh, this is easy, or you're not going to know and you need the answer. And this isn't the tricksy bit. We get into the tricksy bit. So chemical energy, well, energy is shifted from the chemical energy store to, you could say, the thermal store of the car, because the car starts to get warm. Some energy is shifted to the thermal store of the surroundings. The air around the car is going to get warm. And also the kinetic store of the car, because the car is starting to move, right? What happens when the speed of the car becomes constant? Okay, so I have to steal an idea from my very good friend, an excellent physicist, Lewis, over at Online Physics. Physics Online is his YouTube channel. He's got like 200,000 subscribers or something. He's super big time, she says. Not jealous at all. But he does this with Lego bricks, which I think is a really good way of thinking about it. You've got a car. It is stationary. So let's use Lego to represent the energy. Are you all right with the fact that this car is not moving? So it's not shifting any energy. You could say that its chemical energy store is full, and its kinetic store and its thermal store. When I say thermal, we'll say that's the thermal energy store of like the air around it, right, and the car. This is the situation. When the car starts to move, helping your understanding. When the car starts to move, what happens? Well, this energy gets shifted. We've just talked about that. Some of that energy gets shifted to the thermal store of like the surroundings and the car. Some of that energy gets shifted to the kinetic store. What happens when the car starts to travel at a constant speed? Do you like how I'm helping your understanding by just moving a little Lego car? What happens when the car starts to move at a constant speed? Well, it's actually not the case that energy is getting shifted to its kinetic store. If energy kept getting shifted to its kinetic store, sort of a bit like the elastic band, it would get faster and faster and faster and faster and faster. Once it's going at a constant speed, weirdly, energy, like it's still using petrol, right? Energy is still getting shifted from its chemical store, but that energy is, after it's reached a constant speed, is only getting shifted to its thermal store. It's a bit weird, isn't it? It's a bit weird to imagine. And then when it slows down again, then you would say that energy is shifted from its kinetic store. Be careful, where's that going to go? It doesn't go back into the petrol tank, does it? Well, into the chemical energy store. You would say that as it slows down, you've got like friction, haven't you, from between the tyres and the road and the brakes and stuff. All that energy gets shifted to the surroundings thermal store as well. Phew! Is that okay? Oh, that is quite weird. But an object moving at constant velocity, so like a constant speed in the same direction, is not shifting energy to its chemical energy store. Now, this is so complicated that I think your physics teacher 2 years ago, when she was teaching this lesson for the first time, also made this mistake. I showed this to the children. I said, here's an electric fan. You've got a battery and a fan attached by wires. What store is which? And hopefully you can tell me that the battery is a chemical store. And I said that the fan was a kinetic store because the fan is moving and the air is moving. And it was also a thermal store because the fan would be heating up and the air would be heating up. Now, that's true, like the second that you press the button and the chemical energy store of the battery starts to shift to the fan. But I don't think that's true after a while, is it? Because the fan is just going to be going at a constant speed and the air around it is going to be sort of moving in a constant rate as well. So I think that after it started running at a constant speed, it's really only shifting energy from its chemical store to the thermal store. I know. Making simple things complicated since 2020. Okay, have a go at this. I've tried to come up with some questions which I think are really going to check your understanding on this. I made a mistake. If you've got the printout from my website, good for you. It's a great printout. But what happened was I wrote the question perfectly. I put it on the printout and then I went, oh, that question's a bit long. It doesn't really fit on the page. I'll just make it shorter. And when I did that, I've actually made the language slightly less precise, so it doesn't quite work. Are you all okay with the fact that, well, I tell you what, I'll put you in front of the questions and then I'll set up the little demo after that. So what I want you to do, please, you've got the different energy stores here: kinetic, gravitational potential, chemical, elastic strain, nuclear, electrostatic, internal, which sort of means thermal, and magnetic. One of the specifications mashes together electrostatic and magnetic, but we'll split them up for now. Can you please match each of these energy stores to an example of it being filled? Of it being filled. Not it being full, not it emptying, of it being in the process of being filled. So the examples you've got are, and some of these are quite tricky. What I would do is match the ones that you think are definitely right and then go back to the ones that you're not sure about. A bouncy football landing on concrete, tiny pieces of paper starting to move towards a cone, fireworks going into the sky, a book on a shelf, a person eating a banana, an elastic band, an ice cream, an atom forming in the early universe. I've given you that one, actually. That one's nuclear, because we're going to do a whole module on nuclear later, so we don't really need to learn about that now. A comb being rubbed on a jumper, a kettle heating water, magnets that have stuck together, and magnets that have been pulled apart. Now, if you're really paying attention, you might be able to find some situation or heating up, but hopefully you can see what I'm getting at. I'm just going to where's my balloon? Come forward a bit for me. Oh, here we go. Just for the people who might not know what I'm talking about with the little pieces of paper starting to move towards a cone. The terrible noise you're about to hear is just me blowing up a balloon. Okay, I'm going to flip you around, apologies, just for a second. More than a second. So I won't go into this for too much because we've talked about this before and we will talk about it again. But the comb with the paper one, if you imagine that this balloon is the comb, what happens is everything's made out of atoms which have got positive and negative charges. When you rub a comb on wool or a balloon on your hair, what you're doing is you're pulling those charges apart. So they have the potential to move back together again, right? To get attracted to each other. So when I hold a charged balloon, I don't know whether it's a bit more positive or a bit more negative, but it doesn't matter. When I hold that next to some tiny little bits of paper, you will see the bits of paper, and that's the bit that was slightly different on the worksheet. Please use the wording on the screen. Tiny bits of paper starting to move towards a comb. Wow, it's so cool, isn't it? Ah, we have to do that activity again. Anyway, that's what I meant by that. Just in case you weren't sure. I should say, if you've got a Facebook account, then there are some comments on YouTube. Sorry, I'm getting horribly distracted because I've just noticed that a bit of my wall is really wet and I can't work out why. That's so weird. What? It's the weirdest thing ever. I'm like, this lesson didn't involve me throwing a wet toilet roll at the ceiling. I don't know what's happened there. Anyway, I've got a Facebook page, and if you have a Facebook account, you can go over to my Facebook page at the moment, and there's a post at the top saying, comment here if you're watching live. So apologies for there not being any comments on this video if you're watching live. But if you want to tell me some answers, or tell me that you think my answer is wrong, or whatever, then you can go over to Facebook and leave a comment, and I'll read those out at the end. If you haven't got a Facebook account, then frankly, well done you. That is the right answer. Yeah. So, what is it with my wall being wet? Okay, I'm going to file that under worry about that later. Should we go through the answers? Was this really tricky? What do you reckon? Let's go through the answers, because we really should talk about pathways at some point, that being what this lesson is called. An example of kinetic energy. All right. So, well, you might have said a firework going into the sky. That could be true. We're talking about a kinetic energy store being filled up. If the firework is speeding up, then like with the car example, that would be a kinetic energy store getting filled. But we haven't really got enough information to know that. We don't know if it's getting faster. It could be moving at a constant speed, or it could be slowing down. Again, a bouncy football landing on concrete, that is moving, but it's slowing down. So that's not a kinetic energy store being filled. I think it was really mean because it had to do with static electricity. So you might have thought electrostatic, but that tiny piece of paper, if they're just starting to move towards the comb, that would be a kinetic energy store being filled up. That was really mean. I changed the wording on the printout to say something like paper moving towards a comb, which seems like the same sentence, but it's actually not, is it? Because if it was moving at a constant speed, then like that car example, it wouldn't be. Anyway, let's move on. A gravitational potential energy store being filled. I was trying to trick you here. Because when we're talking about gravitational potential energy stores, especially when the textbooks are, we're constantly talking about things being on shelves. And it is true that something on a shelf, you would say, has a store of it has energy in its gravitational potential energy store. It has the potential to fall. So it's storing energy in a gravitational store, okay? As you lift something up, you are shifting energy from your chemical store to the gravitational potential energy store of the thing. Is that all right? So the higher I lift this thing, the more energy I shift to it. I'm filling its gravitational potential energy store. But as soon as I stop, I'm not filling the store, right? It's just, it's a store of energy, but it's not being filled anymore. Is that okay? So I didn't think a book on a shelf was the best example there. Because that's not filling. And it's the same with the bouncy ball. Like, it's coming from high, but it's falling, right? So it's emptying out. It's shifting energy away from its gravitational potential energy store. So I thought firework going into the sky, because that's getting higher and higher and higher. Chemical energy, I've put a person eating a banana, because what is an ice cream doing? An ice cream is just an ice cream, isn't it? That's not an energy transfer. There's no energy being shifted there. The elastic strain one was really tricksy. Well done if you didn't say elastic band, because you realised that I haven't explained what the elastic band is doing. Like, an elastic band, you've got to be really careful. It's so easy in an IGCSE exam when it says give an example of an elastic energy store being filled to write elastic band. But this elastic band isn't getting its energy store filled, is it? It's just sitting there. It would have to be being stretched. So just elastic band wasn't really enough information. So I think person eating a banana is a bouncy football landing on concrete is a better example. Anything basically that is changing shape, like being squashed or stretched, then that is having energy shifted to its elastic store. So it seems weird, but if you could sort of freeze time just as the ball was bouncing onto the concrete, the ball would be squeezing, kind of like the elastic band. It would be changing shape and storing elastic potential energy, and then a split second later it would shift energy from that store to its kinetic store. So it's a bit heavy, this, isn't it? But I must admit, I enjoy this topic a lot. Electrostatic, I've put a comb being rubbed on a jumper because that's charges being forced apart, so they've then got the potential to kind of shift energy by moving together again. Internal energy, well done if you said that a lot of these are examples of thermal energy stores getting filled. Like a bouncy football is shifting energy to like the thermal store of the ground, really, the concrete. But a kettle heating water was the most obvious one. And with the magnetic one, the magnets that have stuck together, that's a bit like something that's landed on the ground, that they've sort of emptied their magnetic store. There's no potential there for anything to happen. But magnets being pulled apart have the potential to snap together. So magnets being pulled apart would be a good example of a magnetic store being filled. Phew! Right, should we move on to pathways? I'm just going to tell you this. Energy is shifted from store to store in 4 different ways, and we call these ways pathways. So we've talked about about the stores. We haven't talked about how energy gets from one store to the other store. So we say that these pathways are mechanical, like by a force, electrical, a current flowing, heating by particles, or heating by radiation. If you've been getting confused and annoyed that there isn't like a light energy store or a sound energy store, then this will help you to understand why. So if I ask you what the pathway is, this battery is a chemical energy store which is shifting energy to the thermal store of the fan and the surrounding air, but what is the pathway? How is energy getting from the chemical energy store of the battery to the thermal store of the fan and the air? Is it mechanical by force? Is it electrical current flowing? Is it heating by particles? Is it heating by radiation? It's electrical, isn't it? So that would be sort of quite an obvious example. We've talked about this a lot before. If you hold a spoon, then what energy store is getting emptied? What energy store is getting filled? And what is the pathway there? Who would have thought that holding a spoon could be so interesting? If you heat up a spoon by holding it, well, you're heating up the spoon because energy is shifting from your thermal store, right? You are a thermal energy store, you are nice and warm, and you're shifting energy to the thermal store of the spoon. And the pathway is heating by particles. So we've talked about this loads, haven't we? This is called conduction. We talked about how the particles in your body are vibrating a lot because they're very hot, and they knock into the particles of the metal spoon and make those start to vibrate more, and that's how the heat is shifted. All right, that was loads of talking, wasn't it? And quite a lot of thinking. Can you light a candle? Let's just have a moment. It's not really an activity, this. I just thought it's more a visual aid than an activity, but don't light a candle unless you've got an adult with you or an adult has said that it's okay for you to light a candle. Let's just have a little think about this, eh? Oh, lovely. So relaxing, looking at fire. Don't hold your candle. There's absolutely no need for you to hold your candle. I'm just trying to make it better, Telly. All right, so you've lit your candle. What is going on here? First of all, the first kind of tricksy question, which it would be good if you understood, and I have mentioned this previously. This is, if you had to answer the question, describe the chemical energy store, how to phrase the question? This is how do I phrase this question? Is it correct to say that the candle is a chemical energy store? Is it correct to say that the candle is a chemical energy store? Yes or no, and explain. Is it correct to say that the candle is a chemical energy store? Yes or no, and explain your answer. What am I getting at here? Do you remember what I kept saying when I was talking about us breathing in or talking about petrol? It's not correct. You would say that the candle plus the oxygen around it is a chemical energy store. If this candle was in space, it wouldn't be shifting any energy at all, would it? The candle plus the oxygen around it is what makes these chemical reactions happen, which shifts energy. So well done for that. Okay, what is actually happening? Well, we've got radiation given off, okay? We've talked in previous lessons about infrared radiation, which is warm. So everything on planet Earth gives off infrared radiation. Everything's warm enough, even ice is warm enough to give off a little bit of infrared radiation. Some stuff is even hotter and is hot enough to give off light. So the candle is giving off infrared radiation, but it's also hot enough to give off light that we can see. So is there some heating by radiation happening here? How are the particles around the candle getting warm? It is indeed heating by radiation. What if, and be careful here please, can you hold your hand about 20 centimetres away from the candle to the side? Probably can't feel anything. You might have to go a bit closer. For goodness sake, don't burn yourselves, be really careful. But you don't have to touch the flame to feel some sort of heating effect. Can you put your hand about 20 centimetres above the candle? Straight away, my hand feels toasty warm. So what is the pathway here? How is your hand getting warm? So energy is being shifted, right? From the chemical store of the candle plus the air around it, plus the oxygen around it. It's been shifted from the chemical store to your body's thermal store, yeah, because your body's getting warm. But what is the pathway? Is it mechanical? Is it electric? which are both types of work, by the way. We did work last week. Is it heating by particles? Is it heating by radiation? Giving thinking time, but not letting you get bored. Oh, teaching's so difficult. I think it's both, right? The candle is giving off radiation for sure, but it must be heating by particles as well, I think, because if you're holding it above, your hand gets much warmer. So why is that? It must be surely because particles of, and we will talk more about this in later lessons actually, but the air particles around the candle are getting warm and they are rising up. Convection, which we've talked about before. So I think the main reason your hands are getting warm is because warm air particles are hitting your hand. So it's heating by particles, but there will also be a little bit of heating by radiation as well, because the candle is giving off radiation. I suppose we better blow that out to be safe, haven't we? It is nice looking at a candle. Okay. Yeah, I've been safe. I've modelled safety. You need to be safe too. Incidentally, you don't need any other equipment. Can you please now heat your hand using a different pathway? Can you shift heat energy to your hand using a different pathway? What? What a weird question. What do I even mean? We just lit a candle and your hands got warm because energy got shifted from the chemical store of the candle and the oxygen around it via the pathway, heating by particles and heating by radiation, to the thermal store of your hand. Go on! I didn't ask them this on Facebook. How are you going to heat your hands using a different pathway? There you go! So you can fill a thermal store in a different way. You're doing work here, aren't you? You're applying a force. And that is shifting energy from your chemical energy store to your thermal store. A bit weird. Right. I'm not delighted by how I laid this sheet out. So if you're a bit confused, it's not you, it's me. But I'm going to give you this to get you just quickly thinking about pathways, and then we'll do a couple of past paper questions. Just very quick, simple ones. Right. Energy is shifted from store to store in 4 different ways. What's the pathway? So all this bit here is just reminding you of the pathways. Mechanical by a force, electrical, a current flowing, heating by particles, or heating by radiation. So I've got these different situations, and I've said, can you put a little M or an E or a P or an R in the boxes to show what the pathway is? So, for example, if energy gets shifted from the chemical store of a power station to a bulb lighting up, what is the pathway there? I should have done like the power station there and the bulb there, shouldn't I, to show it being shifted from one to the other. But I didn't, I'm sorry. So if energy is shifted from the chemical store of the power station to a bulb which lights up, what's the pathway? If energy is shifted because a guitar gets picked up and then you end up holding the guitar, what's the pathway there? Hot chocolate making the mug it's in hot. What is the pathway there? I mean, what are the stores as well? When a hot chocolate makes the mug it is in hot, how is that energy shifting? And if you're done, you can tell me which energy store is being filled and emptied as well. The sun heating earth, what do you reckon? What's the pathway there, the sun heating earth? A torch being turned on and the torch lighting up, what's the pathway there? Lifting a cat down from a shelf. Thank goodness, it's been on that shelf for like 6 lessons. What's the pathway there? And a bulb lighting up and air around the bulb getting hot. So a bulb lights up and air around the bulb gets hot. What is the pathway for that energy shift? And finally, a book falling off a shelf. What's the pathway there? Oh, do you know what? I've just thought of an excuse to light my candle again. It's to help you understanding. How are you doing? I don't really need you to have finished them, actually. Do you think you've done enough? All right, let's go through the answers, because as long as you've done the first few, that's all right by me. So a power station has a chemical energy store. We will talk more about power stations in later lessons. And eventually that energy gets to your home and a bulb lights up in your home. That pathway is electrical, right? Energy is being shifted from the power station to your home via the electrical pathway. If you pick up an electric guitar and then you hold an electric guitar, I suppose you've shifted energy to the electric guitar's gravitational potential energy store, and the pathway is mechanically by a force. You picked it up, you probably pulled it. Hot chocolate, so that's a thermal store, right? Hot chocolate is hot. It goes into the mug, and energy gets shifted to the mug, so the mug would get hot as well. That is heating by particles. Particles of hot chocolate knocking against the mug, making the particles in the mug vibrate more, so they become hot. The sun heating Earth. Well, the sun heating Earth, we will talk more about this when we talk about nuclear, but there's no particles in space, right? So that's not heating by space, that's heating by radiation. A torch being turned on and then a torch lighting up. A torch being turned on and the torch lighting up, that is the electrical pathway. Lifting a cat down from a shelf, you're sort of pulling it down, aren't you? It's a force, so that's mechanical. A bulb lighting up and air around the bulb getting hot. Again, sort of like the candle, I'm going to say that's heating by particles and heating by radiation as well. And a book falling off a shelf, well, it's gravity, but gravity is still a force, right? So you would say that one is mechanical, the book falling off the shelf. You've got to be a bit careful with energy. We've sort of changed how we teach energy in recent years. Like when I started teaching, I would have taught you that sound was an energy store and that light was an energy store. We don't do that anymore. So it's very difficult to teach, actually, if you've been used to teaching it the other way. But it is better this way. So now you would say that light is a pathway, right? In fact, what is light? Light is a type of radiation, isn't it? Just like infrared, visible light. So it's a pathway, but it's not a store. Okay, very quickly we will mention flow diagrams, because you've pretty much seen a flow diagram already, to be honest. I just put a nice picture in there. So when I showed you this, a person heats up a spoon by holding it, the store is thermal, the pathway is heating by particles, and then energy gets shifted like that to the thermal store of the spoon. What you do is, instead of having a nice picture, you put a box there with the first, so write the store underneath, and it's the thermal store of the person. And then the other store is the spoon, the thermal store of the spoon, and you just do an arrow like that. So that is a flow diagram. Energy is shifted from the thermal store of the person to the thermal store of the spoon, and the pathway is particles. I think you're ready for your simple, not easy, but simple past GCSE questions. You ready? Let's do this. All right. So all just kind of, you only need to give like 1 or 2 word answers really for this. It's more about your understanding. So, a hamster runs in a wheel. Can you explain why the hamster's decrease in... Teacher voice immediately jumped in there. Explain why the hamster's decrease in chemical energy is not equal to the wheel's increase in kinetic energy. So you've got a hamster. It's running in a wheel. Obviously, the hamster is sort of, you would say, like burning energy, right? It's using up energy. The hamster is shifting energy from its chemical store. And it's filling the wheel's kinetic energy store. But the amount of energy shifted from the chemical store is not exactly the same as the amount of energy being shifted to the wheel's kinetic store. Can you tell me why? We will do more lessons about that later. A car travelling along a road decreases its chemical store and increases its kinetic store. Describe the motion of the car. So if the chemical store of the car is emptying and the kinetic store of the car is filling, what must the car be doing? And finally, a gas stove is used to melt butter in a pan. Fill in the 4 gaps to complete the simple flow diagram. So you've got a box which says gas plus something, and that is a something store. You've got a box at the end which says melted butter, and that is a what store. And then you've got to say what the path word is in the middle. Might be a bit confusing, that. The melted butter might be a bit confusing. a gas stove is used to melt butter in a pan. So it's gas plus something, which is a watt store. And then you end up with melted butter, which is a watt store. And how does energy get shifted from one to the other? That's your pathway. Really had better blow out my candle now. How are you doing? After we've done this, I'm going to go over to my Facebook page and see if anyone has left me any compliments, complaints, queries. See if people are going, you've been writing backwards this whole time, or you were muted the whole time. That's always fun. Sorry, I got really distracted just looking at the sun reflecting off the sparkly paint on my desk and the smoke going into the air from the candle, and thinking about just how wonderful life is. I have no idea how much time has gone by. So I don't know whether you're all sitting there really bored, or whether you've literally only started thinking about the first question. I think quite a lot of these are, you just know them or you don't know them. And if you don't know them, you probably want me to tell you the answer. I'm going to go through the answers, okay? So look away now if you don't want the answers. A hamster runs in a wheel. Explain why the hamster's decrease in chemical energy is not equal to the wheel's increase in kinetic energy. So we have talked about this, chums, but we will do a whole lesson on it later. But spoilers, some energy is always wasted. If stuff is moving around, you've got friction or air resistance. I think you would need to have said that to get the mark, actually. You've got bits moving against each other. So kind of just like when you rubbed your hands together, stuff is getting warm. And if stuff is getting warm, then energy must be shifted to a thermal store somewhere. So it's not all getting shifted to the wheel's kinetic energy store. So the answer was like friction or air resistance shifts some energy to the air or the wheel's thermal store. Is that okay? I mean, this is the difference between just knowing the answer and getting the IGCSE question right. So you might have said something like, bits rub against each other, so the wheel gets hot. But make sure that we're being nice and precise. Friction is the word you use when stuff rubs against each other. It's a force. And it's the thermal store of the wheel or the air, which is where the energy is going. This was a good one, wasn't it? Did you get this? So a car travelling along a road. It's increasing its kinetic store. If it's increasing its kinetic store, then it must be speeding up. If it was travelling at a constant speed, it would be only filling its thermal store. Is that all right? Oh no, it's a bit tricksy, isn't it? And this last one, a gas stove is used to melt butter in a pan. So hopefully you got that it's the gas. This is the chemical energy store. But it's not just the gas, it's gas plus oxygen, which is making the chemical reaction happen. So the gas plus the oxygen is the chemical store. The melted butter, well, it's heating up, right? So energy is being shifted from that chemical store to the thermal store of the butter. That's the whole point. You want the butter to get warmer. And the pathway, well, the butter is touching the pan. So the pan is heating up. The particles of the pan are starting to vibrate more. So the particles of butter are knocking into those particles, and the particles of butter are vibrating more. So it would be heating by particles. I mean, the pan will be giving off infrared radiation as well, but mainly it was conduction, that one, because talking about solids. Woof! Right, you lot. I enjoyed that. But that wasn't me learning about pathways for the first time. So the main thing is, did you enjoy it? Let's find out. So we've still got 3 weeks. I've had to kind of split this energy topic up a bit. I'm just going to go over to my Facebook page and see if anyone's left me a comment. So we've got 3 more energy lessons. And then I can't quite remember how I've done it, but I think I've taken all the ones that are to do with like power stations and put those in the next module, I think. I need to check my notes. But yeah, we've still got 3 lessons coming up before it's a half-term break. And then when we come back, we'll come back to do energy again. But yeah, we'll sort of take a slightly different angle on it. We'll be looking at how power stations work. Right, let's go over to my Facebook page. If you are new, I mean, I hope you're not new because I had all those sticky problems at the beginning. And also this was quite a weird one to jump in with. But if you are new, hello, welcome. I stream free lessons online. I've been doing it for 5 years. You should totally come to all of them. I do all ages lessons, which are more appropriate for you because you can jump into those at any time. Oh, wow, Facebook. Wow. Just wow. Do you want to see what Facebook's doing? It's just, yeah, I don't know. It's going to be one of those... It's been one of those hours. Look, here's my post on Facebook. And whenever I put the cursor on the post to scroll down and look at the comments, it does that. I get this massive grey line. So all of your comments are covered up. Brilliant. Brilliant. If you're new, how this works is everything is free. The printouts are free. The lesson is free. I've got a first-class science degree. I had to spend money to get that. I had to train to be a teacher, but I'm just pouring those skills into the internet for free. And the idea is that if you can afford £5 a month, then you support me by going to my coffee page. Okay, come on, Facebook, you can do it. Edmund! Oh, you're not feeling very well. Oh no. Oh dear. Okay, all comments. We can do. We've got it. We've got it. It's happening. Bastian is here. I can see Bastian. Bastian, if you breathed warm air, whoa. Bastian says, if you breathed warm air on your hand to heat it, would it be heating by particles? Yeah, definitely. The reason I went, what? Is because you'd be shifting energy from your chemical energy store of your body to your thermal store. Well, you'd be shifting energy from your thermal. It's a bit confusing, isn't it? You've got warm air in your body. That's actually not part of your chemical. You're shifting constantly energy from your chemical energy store to your thermal store, aren't you? Because we're mammals and mammals have to stay warm. So one of the reasons why, even if you sit at home all day in front of a computer planning lessons, you still need to eat food, is because you're constantly shifting energy from your chemical store to keep your body warm. So you're shifting energy from your chemical store to your thermal store to keep your body warm, and that's shifting energy to the air inside your body, and then you're shifting energy from the air to your thermal store of your hand. It's really confused me. Yeah. Yes, Bastian, that's right. Jacob, hello. Andrew, hello. I hope this is you telling me that you found it. You found it. Woo! Good. That's good. And another comment. Michael saying, can you share a link? I hope you found it as well, Michael. If you didn't hear that. And sorry, it's a bit pointless. Hello, Bastian. All right, Jacob, hello. Freya found it, I think. Woohoo! Yes, you did. And he did enjoy it. Oh, that's good. Hello. So Edmund is not feeling well enough. So he's watching live. Oh, no, wait. He won't be watching live, but he's planning to watch on catch-up when he feels better. Oh, that's really nice. I'm so sorry that you're feeling poorly. I hope you're okay, like, long-term. And it's a short-term thing. But anyway, hi, Edmund. Hello from the past. Hello. Hope the future's okay. Hello, Willow and Darcy. All right, Yusuf. The GCSE questions were hard, but also fun. That's nice. That's nice. I've been thinking, I haven't got IGCSE physics. I don't even have GCSE physics. My school only offered sort of double award, which was just a little bit of physics with all the other sciences. Maybe I should do it with you next year. That would be interesting and a bit scary. Right, why is it not letting me scroll down? Come on, Facebook, you can do it. There's Rocklin, hello. Oh, Rocklin, you're so lovely. Finally slotting into place. Oh, good. Yeah, maybe it's quite useful, isn't it, having a sort of recap lesson a few weeks after the first lesson. Hello, Lewis. Oh, I knew that you were here. Hello. Why can't we come on YouTube? Yusuf, it's because I had to throw this video up at the speed of light because I had loads of technical problems. Sorry, and there's loads of buttons to press. I was complaining bitterly at the beginning how Facebook just lets you go live, pew, And then if it goes wrong, you just go live again, pew, and it's the same. Whereas YouTube, you have to set up the whole video like, yes, it's aimed at children. Like, this is the time. Oh yeah, I want it to be public. Oh yeah, I want there to be comments and all this stuff. And then you have to do that all over again if it goes wrong, which I didn't bother to do. Oh, did Michael find me? We tried in 2 different devices. Oh, yeah, it's not the device, it's YouTube making it really difficult to find live videos. I'll type later to see if you found it. If you're watching it now, hiya! I'm glad you found it eventually. Hello, Kai, good to see you. Hello, Joe. Right, let's have a quick refresh and then I will get off, because sorry, it turned into a bit of a long one, this, didn't it, with all the technical problems. Let's do newest comment and refresh the page. No, I don't think there are any. I don't think there are any new comments, so that's easy. There's Freya again. All right, Freya. Newest comments. There we go. Freya is here. No, that's it. Okay, brilliant. All right. Well, Willow and Darcy and Bastian and Rocklin and Andrew and Edmund and hopefully Michael, but we're not sure, and Yusuf and Kai and Jacob and Joe and Lewis. And now I'm worried that I haven't said everyone's name. And Willow and Darcy again. And Bean and Bud. I don't know why I've got into this. And you, Freya, hello. Right, I'm going to go. I'll see you all next week for another IGCSE lesson. Or I'll see you tomorrow if you like watching things that I do on YouTube. I'll see you tomorrow for crustaceans and mollusks and bivalves and what all those words mean. Oceans lesson, which I've really been enjoying. And or seals versus sea lions versus walruses, which I've also been enjoying. I've had a really fun week this week. All right, thanks for joining me. Thank you so much for your support. I will see you all very soon. Bye.